Hey everyone. So today we're going to be looking at the process of gel electrophoresis. So gel electrophoresis is a process that we use to separate DNA by size. And that can be used for all sorts of things. It can be useful for paternity testing. It can be useful for identifying whether a specific gene is present in somebody. And it can be used for forensic purposes as well. So basically, what needs to happen for it, so there's your background information. What needs to happen for gel electrophoresis is, first of all, we use restriction enzymes to cut the DNA into different fragments. Hopefully you remember from when we looked at restriction enzymes cut DNA at specific sites, and due to genetic diversity, people have different numbers of recognition sites. Therefore, for different people, different numbers of cuts will be made, so the DNA will go into different sizes from that. The DNA fragments are then placed into the well of the electrophoresis slab. So an electrophoresis slab basically has little wells at the end of it, and then it's got a positive to negative end with a gel all the way through it. So we load them into the wells of the gel electrophoresis slab, and then we pass an electric current through the DNA fragments. So DNA as a molecule is negatively charged, and therefore it will move towards the positive end of the slab. And what we find is the smaller DNA pieces are lighter, therefore they move further towards the positive end of the slab as that goes. So when the process finishes, we look at the distribution of the bits of DNA, and we can say, okay, the ones that move further must be smaller, the ones that move less far must be bigger. So I've just put an example one here. So these red bits that I've drawn at the top, these are the wells where we load the DNA into. And then down the side, I've got what are sample markers, okay? So these are known fragments that we know the length of that we can use to compare to other ones. So this one might have 2,000 base pairs of DNA. This one here would be 1,500. Here would be 1,000. Here would be 500, for example. So we've got different markers identifying each of those sites. And then we do the DNA fragment for whoever we're testing, the electrophoresis for whoever we're testing the DNA of, and then we could compare these to the markers to get an idea of how big their bits of DNA are. So this person's DNA would be, that fragment would be the same as the marker one, being about 2,000, for example. So this is the positive end, this is the negative end. The further down the fragments move, the smaller the pieces are. And people will get a pretty unique set of bands depending on their genetic makeup, because like I say, we've all got different numbers of restriction enzyme recognition sites due to our genetic diversity. So gel electrophoresis can be used for paternity testing. So for example, we've got the child's DNA here, the pattern they make in electrophoresis here, and we've got the mother's here. And here we've got two potential males who may be the father. So by studying this, what we can see is everyone has this DNA band here, but the mother has this band here as well as the child. This band here, though, is only present in male 1. It isn't present in male 2, and it isn't present in the mother. Therefore, it is very likely that male 1 would be the father because he's given this genetics onto the child. Therefore, they get that band in the gel electrophoresis pattern. So that's a use of gel electrophoresis. It can be used for that as well. And that can also be used for crime scene forensics as well. So if you imagine we find some DNA at a crime scene, we can put it into a gel electrophoresis process and look at the distribution of the bands. And then we can compare that to DNA of a suspect. And if their DNA matches, that may indicate that they were at the crime scene. Not necessarily that they did it, but it may indicate they were present at the crime scene. Finally, just want to make you aware of the existence of gene probes. So a gene probe is a small 15 to 20 base single-stranded DNA piece that is complementary to a specific sequence. And it may be specific to a sequence found in a genetic disorder gene, for example. So the way these link into gel electrophoresis is we can do gel electrophoresis on a single stranded bit of DNA, and then we can expose the probe to the process as well. And theoretically, if the gene that we're studying is present, it should bind to it. And probes can be radioactively labeled as well. So we can just then put a radiation detector over it, and if we see it's attached to a bit of DNA, that would indicate that that gene is present in the sample. So, in summary, gel electrophoresis is a process used to separate out DNA fragments according to size after they've been cut by restriction enzymes. It can be used for paternity testing, for forensics, and to identify if a genetic disorder is present. And yeah, that's about it. So do the work in relation to this. Let me know if you need any help. And yeah, thank you.